In this video, you will be studying decomposition reactions. The essential question we are going to be looking at is, how can I predict the products of a chemical reaction? Just like the synthesis reactions, we are going to assume that all of these actually take place. By the end of this video, you should be able to distinguish between the four types of decomposition reactions, which are defined based on the type of reactant that you are starting with, predict the products for each, and complete and balance the decomposition reactions. The first type that we will look at is when a carbonate decomposes. All decomposition reactions will have one reactant and multiple products. If that reactant has a carbonate ion in it, a CO3 -2 ion, it will decompose into an oxide and carbon dioxide. So our first product is going to be an oxide, which will be formed by the first element, in this case potassium, combined with oxygen. To figure out the subscripts on this, because it's an ionic compound, we're going to look up the charges. Potassium has a charge of +1, oxygen has a charge of -2, so we're going to crisscross those charges and we get K2O as my oxide, and then my other product will be CO2. Once we have the formulas for the products, we need to go through and balance it. There are 2 potassiums on the left, 2 on the right, 1 carbon on the left, 1 carbon on the right, 3 oxygens on the left, 1 oxygen in my oxide, and 2 in my carbon dioxide gives me 3 oxygens on the right. So this is balanced with just coefficients of 1 for everything. If you want to put the ones in, you may, although that is not required. The next one we have is calcium carbonate. So again, we're going to put the first element, calcium, with the oxygen. Look up the charges. Calcium has a +2 charge, oxygen has a -2. So when I crisscross and reduce, I just get CaO, and then my other product will be CO2. To balance it, I have 1 calcium on the left, 1 on the right, 1 carbon on the left, 1 carbon on the right, 3 oxygens on the left, and 1 + 2 gives me 3 oxygens on the right. The last one I have is aluminum carbonate. Again, the first element, in this case aluminum, goes with my oxygen to form the oxide. Look up the charges. Al is a +3 charge, oxygen is a -2, so it will be Al2O3. Plus my other product will be the carbon dioxide. To balance, 2 aluminums on the left, 2 on the right. I have 9 oxygens on the left, 3, 4, 5 on the right now, but we're not really sure which ones we want to change, so save the oxygens for the last because they're in multiple products. And if I look at the carbon, I have 3 carbons on the left, so I'm going to put a coefficient of 3 in front of the carbon dioxide to give me 3 carbons on the right. That gives me 3 oxygens in the aluminum oxide and a total of 6 oxygens in my carbon dioxide, which adds up to the 9 oxygens that I have on the left. The second type is when I have a hydroxide, something with an OH- ion. It is going to decompose into, again, an oxide, but this time the other product will be water. So KOH, I'm going to put the first element, potassium, with the oxygen. Again, look up the charges and crisscross, just like we did earlier. Oxygen has a -2 charge, potassium is +1, so it will be K2O, and water will be my other product. Now for balancing, I have 1 potassium on the left, but 2 on the right, so I need a coefficient of 2 in front of the KOH. That also gives me 2 oxygens, which I have 1 here and 1 here. So I already have 2 oxygens on both sides. That also gives me 2 hydrogens, which I have in the water as well. Calcium hydroxide. My oxide is going to be calcium with oxygen. When I look up the charges in crisscross, calcium is +2, oxygen is -2. So it's just going to be CaO. And my other product, again, because it is a hydroxide, my second product has to be water. Balancing it, I have 1 calcium on the left, 1 on the right, 2 oxygens on the left, 1, 2 on the right, 2 hydrogens on the left, and 2 hydrogens on the right. Aluminum hydroxide, my oxide is going to be aluminum oxide. So put the aluminum with the oxygen, crisscross the charges. Aluminum is +3, oxygen is -2. So it'll be Al2O3 plus water as my second product. Now to balance, I have 1 aluminum on the left, 2 on the right. So I'm going to put a coefficient of 2 in front of the aluminum. At this point, I have 3 times 2, 6 oxygens. But again, we're going to save the oxygen for the end because it's in both of my products. I have 3 times 2, 6 hydrogens on the left, which means I need a coefficient of 3 in front of my water to give me the 6 hydrogens. And that gives me 3 plus another 3, 6 oxygens on the right to balance out the 6 oxygens that I have on the left. The decomposition of a chlorate, something that contains ClO3-, is going to decompose into a chloride and oxygen gas. Again, it's O2 because oxygen is a diatomic. The chloride is going to be formed essentially like the oxide was, but instead of combining the first element with oxygen, we're going to combine it with chlorine. So my first element, K, is going to go with the Cl. Look up the charges. K is +1, Cl is -1. So when I crisscross, I'm going to get KCl, and my other product will be O2. And then I need to look at balancing. I have 1 K on the left, 1 K on the right, 1 Cl on the left, 1 on the right. However, I have 3 oxygens on the left and only 2 on the right. So to balance this, I need the least common multiple of 2 and 3, which will be 6, which means I'm going to need a coefficient of 3 in front of the O2 to give me 6 oxygens, and a 2 in front of the KClO3. That also changes the potassiums and the chlorines, so I need a coefficient of 2 in front of the KCl. Calcium chlorate, I'm going to put the first element, calcium, with the chlorine. Look up the charges. Calcium is +2, chlorine is -1. So when I crisscross, I get CaCl2 and O2 as my other product. 1 calcium on the left, 1 on the right, 2 chlorines on the left, 2 on the right, and I have 6 oxygens on the left, so I need to put a coefficient of 3 to give me 6 oxygens on the right. Aluminum chlorate. The aluminum is going to go with the chlorine. Aluminum has a charge of 3. Chlorine is -1, so AlCl3 plus my other product is going to be the O2. 1 aluminum on both sides, 3 chlorines on both sides. However, I have 9 oxygens on the left and only 2 on the right. The least common multiple of 9 and 2 is 18, so I need a coefficient of 9 here to give me 18 oxygens. A coefficient of 2 will also get me the 18 oxygens, but that also changes the aluminum and chlorine, so I also need a coefficient of 2 in front of the aluminum chloride. The fourth type of decomposition reaction is for binary compounds. Binary compounds are compounds that contain only 2 elements. If there are only 2 elements, the only thing that these can do is decompose into the pure elements. So it's going to break down into each individual element. So mercury with oxygen will break into mercury and oxygen. And the only thing we need to check for is diatomics. Mercury is not a diatomic, however oxygen is. So the oxygen needs a subscript of 2. And now I have 2 oxygens on the right, so to get 2 on the left I need a coefficient of 2 out front, which means I need a coefficient of 2 for the mercury as well. Water, 2 elements, is going to break down into those 2 elements, hydrogen and oxygen. Both of those are diatomics, so I need subscripts of 2 on both of them. There are already 2 hydrogens on the left, 2 on the right, but this only has 1 oxygen on the left and there are 2 on the right. So I'm going to need a coefficient of 2 in front of the water, which means now I have 4 hydrogens, so I need a coefficient of 2 in front of my H2. Last we have NaCl, which again will break down into the 2 elements, sodium, which is not a diatomic, and chlorine, which is. So I need a subscript of 2 with the chlorine, and then to balance it, a 2 here to balance out the chlorines, and then I will also need a 2 in front of the sodium to balance out the sodiums. Here's a mixture of all of the different types, and we're going to go through and make sure that we can identify what type it is and break it down appropriately. AuCl3. The first thing to check for is, does it have only 2 elements? Because that seems to be the one that most people skip over and end up messing up. AuCl3 has only 2 elements. So the only thing it can do is break down into those 2 elements, Au and Cl. The only subscripts we have to worry about with pure elements are the diatomics, subscripts of 2. Chlorine is a diatomic, so I need a 2. Gold is not, so it does not get any subscripts. To balance this, I have 3 chlorines on the left and 2 on the right. So to get to 6, I need a coefficient of 3 in front of the chlorine, 2 in front of my reactant, which means I am going to need a 2 in front of the gold product as well. Next we have CaCO3. That has more than 2 elements, so it needs to be one of the other types. It has a CO3, so it's a carbonate. Carbonates decompose into oxides, which means I need to put the first element with oxygen, crisscross the charges. Calcium is +2, oxygen is -2, and my other product will be carbon dioxide. 1 calcium on each side, 1 carbon on each side, and 3 oxygens on each side. This one will be balanced with coefficients of 1. KClO3. Again, this has more than 2 elements, so I look at the polyatomic ion. It is a chlorate. Chlorates decompose into chlorides, so first element with the chlorine, look up the charges, crisscross, and my other product for a chlorate is oxygen, so O2 will be my other product. And then to balance this out, I have 3 oxygens on the left, so I need to get to 6, so a coefficient of 3 on the right, coefficient of 2 on the left, and then a coefficient of 2 in front of the KCl. FeOH3 has an OH in it, which means it will be a hydroxide. Hydroxides are made up of oxides, or decompose into oxides, so I need to put the iron with the oxygen, and then my other product is going to be water. All right, now for crisscrossing with the iron oxide, I have to be careful because iron can form multiple charges. However, whatever charge it had on the left-hand side, I need to use on the right-hand side as well. If you use a different charge, it ends up being impossible to balance. So the iron here, I know has a +3 charge because each of the hydroxide ions has to have a -1 charge, and there are 3 of them. So I need to use the +3 charge on the iron. Oxygen has a -2, so Fe2O3. To balance out the irons, I know I need a coefficient of 2 here. If I look at the hydrogens next, I have 3 times 2, 6 hydrogens, so a coefficient of 3 here. And that also balances out the oxygens and gives me 6 on both sides. You can also do this with the names being given to you. You just need to write the formulas for the reactants as well. So if I have nickel 3 hydroxide, that means I'm putting nickel with hydroxide. This is a compound, so I need to crisscross to get my subscripts. Remember, the Roman numeral 3 tells me the charge on the nickel. Hydroxide, polyatomic ion, it has a charge of -1, so this would be NiOH3. Yields, it's a hydroxide, which means it's going to break into an oxide, so nickel with oxygen. And it's already told me that it's a nickel +3 over here, so I know I need to use the +3 charge. So Ni2O3 plus my other product for any hydroxide decomposition is water. One nickel on the left, 2 on the right, so I need a coefficient of 2 here. I have 6 hydrogens on the left, so a coefficient of 3 balances out the hydrogens, which also balances the oxygens. The last one that I have here is copper 2 chlorate. So copper we know is Cu. Chlorate is ClO3. It has a -1 charge. This tells me that I'm using a +2 charge on the copper. So CuClO3, 2. Chlorates decompose into chlorides. So the copper ends up with the chlorine. And again, I need to use the same charge that I used on the left. So I need to use a +2 charge on the copper. Chlorine has a -1 charge. And my other product will be oxygen. 1 copper on the left, 1 on the right, 2 chlorines on the left and right, 6 oxygens on the left, so I need a coefficient of 3 to balance out the oxygens on the right. Magnesium carbonate. Magnesium is Mg. Carbonate is CO3. Magnesium has a +2 charge. Carbonate has a -2 charge. So if I were to crisscross those, it just gives me MgCO3. Carbonates decompose into oxides. So I'm going to put the magnesium with the oxygen. Again, magnesium has a +2 charge. Oxygen has a -2 charge, so I just get MgO when I crisscross. And for carbonates, my second product is CO2. If I go through and count atoms, this ends up being balanced with coefficients of 1 on everything. Lastly, I have sodium oxide. Sodium is Na. Oxide, I'm going to put it with the oxygen. Look up the charges in crisscross. Sodium is +1. Oxygen is -2, so Na2O. This only has 2 elements, so it's the binary that breaks down into what those elements are. So it's going to break down into Na plus oxygen Oxygen is a diatomic, so it gets a subscript of 2. So to balance this one, I have 2 oxygens on the right, but only 1 on the left. So I need a coefficient of 2 to balance out the oxygens. That gives me 4 sodiums on the left, so I need a coefficient of 4 here to balance the sodiums on the right. So remember, a decomposition reaction will have one reactant, and it will break into 2 products. You will be given on any testing quiz that carbonates decompose into oxides and carbon dioxide. Hydroxides decompose into oxides and water. Chlorates decompose into chlorides and oxygen. And binary compounds decompose into pure elements. You need to be able to identify which type each compound is and decompose it appropriately. Remember, whenever you are writing the formula for a compound, you need to look up the charges and crisscross. If it's something that has more than one possible charge, whatever charge is used on the reactant side, you must also use on the product side.